My name is Travis Quick, and I teach chemistry at Hardin Valley Academy. The handout that accompanies this video can be found on the KCS website under the Student Resources tab. This is Chemistry Activity 2 for high school chemistry. Today we are going to be learning about stoichiometry. And stoichiometry can be thought of in this way. It is the relationship between the relative quantities of substances that are taking part in a reaction or forming a compound, typically related by a ratio of whole integers. This ratio of whole integers comes from balanced chemical equations, and from these, the coefficients in front of each substance give the number of moles for each substance. This relationship between numbers of moles is the mole ratio. And next we'll see a very short summary from Chemistry Activity 1 dealing with mole-to-mole conversions. So in this fictitious reaction, we have 3A reacting with 1B to form 2C plus 4D. And in order to go from moles of anything in this reaction to moles of something else, we need to have the mole ratio between the two substances in question. For example, if I wanted to turn 3 moles of A into a certain number of moles of D, then I would need to use the mole ratio that you see there at the bottom. So 3 moles of A are given. I can use the conversion factor 4 moles of D over 3 moles of A, and when we do our calculation, we see that we come up with 4 moles of D. And the way that this is set up, the moles of A will cancel, and so the only unit that we are left with is moles of D, which was what was wanted in the answer. Pause the video now and try a quick mole-to-mole conversions page in the Chemistry Activity 2 packet. So, moving on to stoichiometric conversions. As you saw in the Chemistry 1 activity videos, we can have a mole island for a given substance. Let's call that substance A. And in this mole island, we can convert from grams to moles, liters to moles, or particles to moles. Or we could do grams to particles, or liters to grams. It just depends on what is asked for in that particular question. We could also do this for a completely different substance. Let's call it substance B, with its own mole island. The only difference between the substance A mole island and substance B mole island is that the molar mass would differ between the two substances because they are different. But how we use those values would be very similar. So if we want to make the jump to go from substance A over to substance B, then we would need to use that mole ratio, which is going to come from the balanced equation, those coefficients in front of the particular substances. So if we start with a given amount of grams of substance A, we can follow a path to get us to our unknown grams, let's say, for substance B. So if I start with the given grams of A and using the molar mass of substance A, I can divide by the molar mass, as you see there, and convert that into moles of A. And in the way we have this set up mathematically, the grams of A will cancel out. We want to continue onward to figuring out grams of B. So we need to now use the mole ratio. So we need the balanced equation here, whatever that would be. And we would have moles of A in the denominator, moles of B in the numerator. And again, with this mathematical setup, moles of A will cancel out. But we don't want to stop here. We want to continue on to calculate grams of B. So we need to take one final step and convert that using the molar mass of B, whatever that may be. And again, how this is set up, moles of B will cancel, and we will end up with the unit of grams of B. And then we would do the math, multiplying and dividing, to figure out the numerical answer. Let's try a real example. So if we're trying to create water from hydrogen gas and oxygen gas, we might have a problem such as this. How many grams of water are made when 15.3 grams of hydrogen gas are used? Some important things to think about before solving this question. Let's think about what are we given, what information do we know? And that would be our 15.3 grams of hydrogen gas. And we also want to identify what we want to figure out. And in this case, that would be how many grams of water could be produced in this situation. So if we begin with our 15.3 grams of hydrogen, we're at that first step, so we're going to want to convert grams of hydrogen to moles of hydrogen. So we need to divide by the molar mass of H2, which you can calculate very easily from the periodic table. At this point, our grams of H2 will cancel out, and if we stopped here, we would end up with moles of H2, which is not what we want. So we need to take another step. We want to convert to moles of hydrogen now, and we can use that mole ratio from the balanced chemical equation. And in this case, it works out to have the same number for each substance. That's simply because of how the equation balanced out. So we would have 2 moles of H2O in the numerator and 2 moles of H2 in the denominator. And again, having it set up this way, moles of H2 are going to cancel out. But we don't want to stop here. We'll take one final conversion, and we're going to convert moles of H2O into grams of H2O, and we need to multiply now by the molar mass of H2O, which is 18.015 grams of H2O. Again, the way that this is set up, the moles of H2O will cancel, and now the only unit that has not been crossed out is grams of water. That is what we wanted, so that's good to have that left over. Now we need to figure out the numerical portion of this. So, starting from the left there, 15.3 times 1 divided by 2.016, we would have an answer. Then we can multiply that by 2, and then divide that by 2. And then that result, we could then multiply by the 18.015 and end up with a mass of water of around 137 grams. So here's a different equation. We have aqueous copper chloride reacting with solid aluminum to produce aqueous aluminum chloride and solid copper. It's already been balanced for you. There are 2 examples which will be similar to what we just practiced with the production of water. If you pause the video here, you'll be able to do your work and come back to check your answers for these 2 conversions. So, for our 2 examples here, in the first, if 171 grams of aluminum were used, we could create 604 grams of copper following very similar conversions to what we did previously. And then with 259 grams of aluminum chloride being produced, we could create around 392 grams of copper 2 chloride. We would require 392 grams of copper 2 chloride. So as a review of stoichiometry conversions, we focused on one particular set of conversions that are used a lot in chemistry, the gram to gram conversion. But this mole island will truly let you convert between any two substances in a chemical reaction. As long as you know that mole ratio, you can do that. For example, if I start with liters of substance A, I could turn that into particles of substance B. And how we would get there is first I would need to convert the liters of substance A by dividing by 22.4 liters. That would give us moles of substance A. And then by using the mole ratio of substance A to substance B from the balanced equation, we could convert to moles of substance B. And then finally, we could multiply by Avogadro's number to come up with particles. To conclude this activity, try the gram-to-gram conversions page in the Chemistry 2 activity packet.